Hey guys, it's Ivana and welcome to Intellecta. In today's video we are gonna be solving two equations using the Lambert W function. We are gonna find all possible real solutions considering W sub 0 and W sub -1 branches. Before we get started, please make sure to subscribe to help me hit that milestone of 1000 subs. Now, let's get started. So the first equation we are going to be solving is x squared is equal to 2x. Let's see how does it look like on the graph. If you take a look, you will see that we have three intersection points. That means we will have three values of x. So solving this equation, we will get three x's, two of which are going to be positive and one is going to be negative. If we forget about this graph, how can we say how many solutions should we get if we don't know how does it look like on the graph? So I'm going to show you that. So just using the Lambert W function, you can figure out how many solutions should you get. And now, how could we solve this equation here? We have two ways of solving this equation. The first one, if you take the logarithm of both sides, so let's show it, we will have 2 ln of the absolute value of x is equal to x ln 2. And now, you know, if we consider the absolute value, we will have x for x is greater than or equal to 0 and negative x for x is less than 0. That means we are going to have two cases to consider. The first one for x is greater than 0 and the second one for x is less than 0. So this is if we use the logarithms. And now the second method, if you take the square root of both sides, and you will get this. So let's say we took the square root of both sides, and we have x is equal to what? Plus minus square root of 2 to the x. And it's the same as plus minus 2 to the x over 2. Am I right? And now, you have two cases as well. The first one, x is equal 2 to the x over 2, and the second one, x is equal to negative 2 raised to the x over 2. And now you can solve both equations using the Lambert W function, and you will get the same value as if you consider this equation here. So you can choose whatever you want. For this video, I will take this equation here, and I'm going to use the Lambert W function for solving it. You can try this other way, and you can write in the comment section if you got the same result. Okay, now, so this is our equation. So the first case is for x is greater than 0. So this is our first case. And what do we have? If x is greater than 0, then we have ln of x, and then, so 2 ln of x is equal to x ln 2. So remember, we want to get this form here, x e to the x is equal to some constant. That's why we want to have all x's on the one side, and we will have 1 over x times ln of x is equal to 1 over 2 ln of 2. Okay, now, how can you rewrite this 1 over x? 1 over x is nothing else than e raised to the ln 1 over x. So you can cancel these two out, and you're left just with 1 over x. That means 1 over x or e to the ln 1 over x is the same. So we have ln x times e to the ln 1 over x is equal to 1 over 2 ln of 2. And now, as you know, we want to have the same expression here in front and here in the exponent. Do we have? At this point we don't have, because we have ln of x and here ln of 1 over x. So we want to have 1 over x here as well. What should we do? So let's multiply by -1, and then we can move this -1 here to the exponent, and then we will have the same. So times -1, and now negative ln of x times e to the ln 1 over x is equal to negative 1 over 2 ln of 2. Okay, let's move this -1 here to the exponent. So we have 1, and we will have ln of 1 over x times e to the ln 1 over x is equal to -1 over 2 ln of 2. And as you can see, we have the same expression here and here. And what should we do? Now let's apply the Lambert W function. So we are going to apply w, and we have w of ln 1 over x times e to the ln 1 over x is equal to w of -1 over 2 ln of 2. And now we have to stop here for a little bit. Why? So remember at the beginning I told you we can figure out how many solutions do we have using just the Lambert W function. If you don't know how does it look like on the graph, you can figure out from this here. How? So we have w of this here is equal to w of -1 over 2 ln 2. This here is our x. And we know, you know, in my first video about the Lambert W function, I explained that our x has to be greater than or equal to -1 over e. And it's here as well. So we have 1 over 2 times ln 2 is greater than -1 over e. But there is one more thing about this. So from this here, we can figure out how many values should we get for our solution. And now, if this here, this x, is greater than 0, then you will have just one solution, and it will be for w sub 0. You know, we have two branches, w sub 0 and w sub -1. W sub -1, and if we consider just real numbers, we will assume just these two branches. And now if our x is greater than 0, we will get just one result, and it will be for w sub 0. If this x here is less than 0 and greater than or equal to -1 over e, then we will have two solutions, and it will be for w sub 0 and for the branch w sub -1. So we will have both solutions. In our case, it means we are going to get two solutions because our x is less than 0 and greater than -1 over e. Now let's solve this for x. So we have w of ln 1 over x equal to the same. We have our x is this here, our expression is this here, and we will have just ln 1 over x is equal to w of -1 over 2 ln of 2. And now we have as base e raised to this gives us this here, and we have 1 over x is equal to e to the w of -1 over 2 ln of 2. And what would be our x? So now we have that our x is equal to e to the -w of -1 over 2 ln of 2. So let me write this once again. So we got that x is equal to e to the -w of -1 over 2 ln 2. And if you enter this, if you use the Wolfram alpha to find the value, you will get that this is equal to 2. So what does it mean? Where is our second value, our second solution? If you have something like this, that means this is for the branch w sub 0. Whether you have w or w sub 0 is the same. You will get the same result using the Wolfram alpha. And how can you get the second solution? The second solution, we said we are considering just two branches, w sub 0 and w sub -1. So the second value, the second expression, you can get also using the Wolfram alpha. You have to enter something a little bit different. It will be, instead of this here, you will have to enter product log of negative 1 and this here, negative 1 over 2 ln of 2. So for w sub 0, you will enter the same, e to the product log of negative 1 over 2 ln 2. And for this here, for w sub negative 1, you will have to enter product log negative 1 comma negative 1 over 2 ln 2. So now you know how to use Wolfram alpha to get two solutions. And once again, according to this here, we know that we should get two solutions, and here it is. So we have two solutions. If you if you enter this product log of this here, you will get that x is equal to 4. But how can we get this expression for w sub negative 1? How exactly can we get this expression for the x if we consider w sub negative 1? I'm going to show you now. So the first expression for the x you get from this equation here will be for the branch w sub 0. And I said I'm going to show you how to find this expression for the x if we consider this branch w sub negative 1. So you can get it if you find another way of how to write out this expression here. How can we do that? So you can see we have negative 1 over 2 ln 2. We can rewrite it, so we have negative 1 over 2 ln of 2. How can we rewrite this? So here is negative 1. We can move it here to the exponent, and then we have 1 over 2 ln 1 over 2. But if you take a look, you will see that it's the same as 1 over 4 ln 1 over 4. How? If you rewrite this here as 1 over 2 squared, so you have ln 1 over 4 ln 2 squared, you can move this 2 here to the front, and then this 2 and this 4 are going to cancel, and we are left just with 1 over 2 ln 1 over 2. So this here is true. That means this expression here is the same as 1 over 4 ln 1 over 4. But what happens if you apply w to it? So if you apply w, how can you rewrite this even more? 1 over 4 is nothing else than e raised to the ln of 1 over 4, isn't it? So you can cancel these two out and you will get just 1 over 4. And now, that means this here is equal to ln 1 over 4 e to the ln 1 over 4. And if you apply w to this here, what are you gonna get? So w to this here, remember this expression here is the same as this expression now here. What can you get? You will get w of this here is just ln of 1 over 4. Okay? So this is just ln of 1 over 4. That means this expression here we can rewrite as, so this here is equal to ln 1 over 4. Now we have w of ln 1 over x is just ln 1 over x. It's equal to, I explained why w of negative 1 over 2 ln of 2 is equal to 1 over 4 ln of 1 over 4. And now you have e raised to this here gives us this here. We have 1 over x is equal to e raised to the ln 1 over 4. And what is our x from this here? X is equal to e to the negative ln 1 over 4. Even further, what is this? 4 raised to the negative 1, the negative 1 goes to the front, and we have e to the ln of 4, e and ln we can cancel, and we have just 4. So we get the second solution, we get that our x is equal to 4. So the thing is, you don't have to do this. You can take advantage of the Wolfram alpha and you can get both expressions, both results, both values. It's just important to get that first x, and then you can you can, using the Wolfram alpha, find both values. I just wanted to show you how can you from this expression here get the second value if you don't want to take advantage of Wolfram alpha. So for x is greater than 0, we got this here, and we had two solutions, x is equal to 2 and x is equal to 4. So, and now let's consider that our x is less than 0. So now let's take that our x is less than 0, the second case, and we will have 2 ln of negative x is equal to x ln of 2. And now, once again, we have to move all x's to one side and all constants on the other side, and then we will have 1 over x ln negative x is equal to 1 over 2 ln of 2. We have ln of negative x. Rewriting this here 1 over x, what do we have? We have e to the ln 1 over x. And if you rewrite this here, you will have e to the ln of x raised to the negative 1. This negative 1 goes here to the front, and we have e to the negative ln x. But we need negative x here as well. That's why we are going to first multiply both sides by negative 1. And forget about this here. So now what do we have? We have negative 1 over x times ln negative x is equal to 1 over 2 ln 2. Now let's rewrite this negative 1 over x in order to have our e, because we want to have this expression x e to the x is equal to some constant. So we want to have this e, and that's why we have 1 over x is equal to e raised to the ln of negative 1 over x. Rewriting this here, we will have e to the ln negative x to the negative 1. And now let's move this negative 1 here to the front, and we have e to the negative ln of negative x. So we got that negative 1 over x is the same as e to the negative ln of negative x. Okay, and now we have ln of negative x times e to the negative ln of negative x is equal to negative 1 over 2 ln of 2. We want to have the same here and here. Do we have? No, we don't. That's why we have to multiply by negative 1 times negative 1. And now negative ln of negative x times e to the negative ln of negative x is equal to positive 1 over 2 ln of 2. What should we do now? Now should we apply? We have the same here and here. We should apply Lambert W function. This is too small. And we have w of negative ln of negative x e to the negative ln of negative x is equal to w of 1 over 2 ln of 2. Okay, what now? If we have this here, we will get just this here, and we have negative ln of negative x is equal to w of what? 1 over 2 ln of 2. Now we are going to multiply by negative 1. Okay, let's do it first. Negative 1. So we will get that ln of x, of negative x, is equal to negative w of 1 over 2 ln of 2. Now negative x is equal to e to this here, e raised to negative w of 1 over 2 ln of 2. And now multiplying by negative 1, we will have that x is equal to negative e to the negative w of 1 over 2 ln 2. And this is our x, so we got expression for our x. Now, how many values should we get from here? Let's say this here once again. We have w of 1 over 2 ln 2, and we've said in the previous case when x was greater than 0, we said if this x is greater than 0, then we are going to get just one value. That is in this case here. We have that 1 over 2 ln 2 is greater than 0. That means we are going to get just one value, just one solution. And this solution is going to be for w sub 0. So always when you have one solution, it's always for w sub 0. That's why if you use Wolfram alpha, you will get that x is approximately negative 0.7666 and so on, something like it. So our x is approximately negative 0.7666 and so on. So at the beginning we had this equation here and we got three solutions. We had to consider two cases for x is greater than 0 and as x is less than 0. For x is greater than 0 we got two solutions, two values. For x is less than 0 we got just one value. Now let's do the second equation. This second equation I've already explained in one of my videos. In that video where I was comparing the Lambert W function and the glog function, you can take a look. And now you asked me to explain all possible solutions. In that video I explained just one solution because I just wanted to compare these two functions. And now I'm going to show you how to get the second solution and how do you know how many solutions do you have. So on the graph you can see that we have two intersection points. That means we are gonna get two values for the x, and now let's see how can we figure out from this equation here how many solutions should we get without this graph. Okay, I'm not gonna do the whole procedure. I'm just gonna show you this equation here, so you can watch in my previous video once again. So w of negative x ln of 2 e to the negative x ln of 2 is equal to w of negative ln 2 over 10. Now, as I already said, this here, if it's greater than 0, you are gonna get just one solution. If it's less than 0, you are gonna get two solutions. In our case, it's less than 0. That's why we are gonna have two solutions. And our solution x is equal to negative 1 over ln 2 times w of negative ln 2 over 10. So this is our x. Now you know this first x you get is for the w sub 0, so you can enter this same equation and you will get the value for the branch w sub 0. If you want to get for w sub negative 1, you will have to enter product log, once again, product log negative 1 comma negative ln 2 over 10. And you will get the value for the w sub negative 1 branch. In the first case, in this case here, for w sub 0, you will get that x is approximately 0.107. And in the second case, you will get, so for the w negative 1, you will get that x is approximately 5.877. So as you saw on the graph, we had two intersection points, so we figure out from this here that we are gonna get two values, and the first one is 0.107 and the second one is 5.877. So if you want to get x for w sub negative 1 branch, you have to play a little bit with this here. I'm not going to show you this in this video because it's too long so far. And so yeah, You can play a little bit with this and you will get the second value, but I don't think you have to do this. You have Wolfram alpha, take advantage of this Wolfram alpha and find that x for the w sub -1. So it was it for today. I hope it was helpful. If it's so, please leave a like, subscribe if you haven't already, help me reach that goal of 1000 subs. And till the next video, please watch my video about the Lambert W function and about the application of the Lambert W function. And till the next time, stay healthy, stay positive, and do some math.